Hello, scholars. And I should say scientists. It's Miss Hazel here. And we have an experiment today. So here's the situation. We went on a field trip. We were going in a nice little boat, having a good time, having a picnic. We were going to get to swim in the ocean, but then the boat crashed into some rocks. And now we're on a deserted island. And all you have is a bathing suit. And our lunch bin washed up the shore. And the thing is, okay, yeah, the clothing that you're wearing, because it's a bathing suit, is waterproof. But you're stuck in the sun, and the sun is so strong, and it's just beating down your head. And you're like, oh, I need to make a hat. But I only have the materials from our lunch bin. Everybody has a paper towel, a paper plate, a brown paper bag, and a piece of aluminum foil. So I'm like, okay, well, how am I going to put this hat together? And then, Miss Hazel came in clutch. She has a bunch of binder clips. Okay, so that might help keep things together. And, I guess we were going to do an activity with some string. We have some string. So our task is to make a hat. Now, let's think about what properties we want our hat to have. Let me think first. Why do I like this hat so much? Well, it does look cool, you're right. But that's not what's important here. I like it because it's soft. So the first one is it's soft. Next. I wear it for style, but I also like to wear it when I go out and the sun is really shining. Okay? I like it because it soaks up sweat. It soaks up sweat, or it is waterproof. If it gets wet, it just soaks it up. And last but not least, see this brim here? This brim is nice and we call it stiff, right? So it protects my face and it makes the hat strong. Okay? So we have 3 properties that we want our hat to have. We want it to be soft, so softness, soaks up sweat, is it waterproof, and stiffness, does it stay together, right? Does it protect you? So we're going to test out our materials. First, we'll test for softness. So that's nice and easy, right? I will just decide if each material is soft or not. Yeah, paper towel soft. I'm rubbing my hand on it, seeing if it's nice and smooth. Paper plate's pretty smooth. This feels a little rough, so if I use this for my hat, I might not want it touching my head directly, okay? Yeah, maybe I will want one of these two. And, yeah, this is okay. Alright, now we're going to see if it soaks up water. So the best way to test if it soaks up water is to, well, use water. I'll be right back. Yeah, Gigi, alright, I got too excited. I forgot to get all my materials beforehand. Relax. Oh, man. Alright. So, I'm going to just get a little bit, see, and see what happens. Alright, yeah, so that's why we like paper towels, right? The first time we spill something, we say, yeah, let's get a paper towel. So the paper towel soaks up water. Good. Let's see about the paper plate. This might be a little hard for you guys to see. Yeah, let's see. Now, because it's white, it looks like it could look like it soaked it up. But notice how the water, I keep moving it, and it keeps going. So it doesn't soak it up, it just kind of lays there. So the paper plate is not waterproof. Okay, so we'll keep that in mind. The paper plate is not waterproof. Let's see about our lunch bag. Yeah, it's kind of the same thing as the paper plate. This isn't waterproof. It's still, the water's still there. It's just moving around. All good. And our tin foil. Yeah, I know this is hard to see on a camera. Alright, so yeah, it looks like the tin foil absorbed a little bit more of the water, but it still didn't work as well as the paper towel did. So I'm going to keep in mind that the paper towel is by far the most waterproof material we have. Okay? Alright, and we have one more test. We need to see how stiff each material is. Okay? So, when we test for something's stiffness, a good way to test that let's see if I can get, I'm trying to see if I can get the video because I really like it, but I'm not sure it's going to work. If it doesn't work, I'll just tell you how to do it, so it's not a big deal. Let's see.
Stiffness test. Hold each
Okay, yeah, so I can't show it on my screen to you guys, but that's okay. Because I'll just show you how to do it. So now, you want to hold each material and see if it droops down or not. So this guy, the aluminum foil, isn't drooping down. So it's pretty stiff. Yeah, this is definite. The paper plate is definitely more stiff than the aluminum foil was. Now let's see about the paper bag. Yeah, it's pretty flimsy. And last but not least, the paper towel. Yeah, it's extremely flimsy. Okay. So I think probably the strongest that we have are the paper plate and the paper bag. So now here's where the creative part comes in. You can use all the materials, or you only have to use a couple. It's whatever you want. You have your tin foil, the brown paper bag, the paper plate, and your paper towel. Now I have 4 binder clips. If you don't have these at home and you want to do this, you could use clothespins, or you could also use tape, just something to keep your materials in place. And you don't need this, but it might help. Maybe if you have some string or yarn somewhere. Okay. So there we go. I'm going to try and make a hat. Alright, so I'm keeping in mind that the paper plate and the paper towel were the softest materials. So I probably want those to be touching my face or my skin. But this was a strong material, so this is important. Let's see. And I want to make sure that, like, my Phillies hat has a brim, that I have a brim on my hat to protect myself from the sun. But this might be rough on my skin, so I'm going to put this under here.